Video on radical equations and solving radical equations. 4 steps in radical equations. Isolate the radical and identify the index. The index being this it's the opposite to an exponent, really. But there it is. We raise both sides of the equation to that power, to the reciprocal power. We solve for the variable, and then we check our answers. We've got to plug them in to check to make sure that they work, because there may be some solutions that don't work. So let's take a look. Let's get started. All right, first of all, before we get started, we're going to take a look at solving an equation for a variable, right? Just once again, a quick review, if you will. So to solve an equation for a variable, we perform inverse operations, right? So the opposite, if you will, right? So in this case, we're adding 3 to both sides. We get ourselves 7x equals 28. And then we divide by the coefficient of that variable, and we get ourselves x equals 4, right? We're satisfied that x is always equal to 4 in this kind of situation, right? What if you get this with, instead of having x, you've got the square root of x, right? Well, everything else works exactly the same way. We just still add 3 to both sides, right? We still add 3 to both sides. We get ourselves 7 times the square root of x equals 28. And once again, we divide by that coefficient by the 7, and we get ourselves the square root of x equals 4. Now, the square root of x equals 4, to get the opposite of the square root, or the inverse operation to square roots, is raising to the power of that root, or that radical. In this case, our index is a 2. You don't see it because it's a square root. So we're going to raise both sides of this to the power of 2, and we get ourselves x equals 16. Right. One last step. We do need to check our solution, right? So let's check our solution, right? Make sure that this x equals 16 actually works, right? So let's plug in 16 into the original equation and see that it works. So we can do this using a calculator if you like. You just do 7 times the square root of 16 minus 3 equals 25. You'll find that the square root of 16 is either positive or negative. So this is either positive or negative 4, right? And you'll see that for positive 4, so for positive 4, this is indeed true. Okay? So there is two possible answers, I suppose, but in this case we're looking just at x equals 16 is what we solve for. So that is a true solution. Okay, we're good. Let's go and try another one. Okay, this one here, as we can see, has an index of 3. So let's get to that index. We're kind of using the same problem. If you see here, we're just down at the 7 times root of x equals 28, but we've got something different going on in here. So let's divide both sides by 7, right? And we have ourselves the cube root of 2x equals 4. Right, so now we're raising both sides here to the power of 3, right, to get rid of this cube here, this cube root. Okay, so that will then give us 2x equals 64. 4 to the power of 3 is 64. Right? Okay, so now we've got another step to do with our inverse operations. We divide by that coefficient. Right? Remember, you can't do that before you do the root. It's like having parentheses around it. You got to do the root. You got to do everything in order. So we then get ourselves x equals 32, and that's what we're going to work from. All right. So we've solved for our variable x equals 32. Let's plug that into a calculator. 7 times the cube root of 2 times 32. If you plug this into a calculator here, you will indeed get 28. Okay, so that's a good solution. All right, let's move on. Hopefully that all makes a little bit of sense to you, and we can do a little bit of practice. If it all makes sense to you at this point, pause the video, come back after, say, 2 questions, check your solutions, and we'll do it again. All right. All right, next two problems here we're going to take a look at. Yeah, they're very similar, as you can see, right? In this case, once again, we're going to divide by that coefficient. We've got to get to that radical, so now we have x plus 1 equals 4, and we subtract 1 from both sides to get ourselves x equals 3. All right, so is this true? Once again, you want to plug this x equals 3 into your Okay, let's take a look at what we've got here. Once again, it's a similar kind of problem. We're going to divide both sides by 7, and we get our square root of x plus 1 equals 4. So once again, we're at the situation where we're going to raise this to the second power on both sides, right? And so now we have x plus 1 equals 16, right? And so we've got to isolate the variable, so let's subtract 1 from both sides, and we have ourselves x equals 15. Well, once again, let's plug that into an equation, make sure that it works, right? Make sure that x equals 15 works in your problem. So 7 times 15, the square root of 15 plus 1 equals 20. It is, if you plug this into a calculator, is indeed equal to 28. One of the things that you want to watch out for here is, of course, that a square root here, the square root of 16 is what it is going to have two solutions, both positive and negative 4, and this, of course, works for positive 4. But if this was a negative 28, it would also be true. Okay, so that's just something that's worthwhile noting right here. Okay, same problem essentially. All we're doing is we're starting with a negative 3 on the outside, so we're going to add 3 to both sides, and you'll see that we get ourselves 7 times the square root of x plus 1 equals 28, and we know that's true from right here. So once again, we're down here to dividing by 7 on both sides. We get ourselves the square root of x plus 1 and equals 4, and we are raising that to the second power. This is the important step that I want to highlight always. We're raising it to the second power, right? Raising that to the second power. There we go. Raising that to the second power, we get ourselves x plus 1 equals 16, and so x equals 15, and we can see that that's true from before. Once again, feel free to pause this video, and we'll move on, and before moving on to the next problems, I'll catch up with you on the other side. All right, what we're going to look at now is we're going to look at the other solutions that we haven't really talked about a lot, right? Same kind of idea here. We're still working roughly with the same problem, but check this out. We've got ourselves a negative right here. So we're now dealing with the square root of x plus 1 equals negative 4, right? So when we raise this to the second power, watch what happens, right? Watch what happens. We're going to raise this here to the second power. That's going to give us x plus 1. And we're going to raise this here to the second power. That's going to give us, well, negative 4 times negative 4 is positive 16. And of course, in this case, we're going to subtract 1 from both sides. So we're going to subtract 1 from both sides. We get ourselves 15. X equals 15, right? So let's check this, right? So we have x equals 15, right? Is this actually going to work in this situation? So let's plug it in and find out, right? So if you put in 7 times the square root of 15 plus 1 into a calculator, you're going to actually get 28. We've seen this before, right? You're going to get 28. You're not going to get negative 28, right? So 15 doesn't actually work for this, right? these two here are not equal. They're not equal, right? So this is what we would call, this here is what we would call, change colors here so you can see it, an extraneous solution. Right? We actually know that if we, for this to actually work, for this 15 here is not going to work for us, right? We're going to need to have something different, all right? So that's an example there of an extraneous solution. Let's look at another problem, and this time the same problem, essentially the same problem, and this time we have you'll see a cube root, right? So when we divide by 7 on both sides, we still have that negative, but we now have cube root of x plus 1 equals negative 4. All right, and if you know anything about cube roots, you'll know that these are going to change the sign, right? Because when you multiply a negative times a negative a couple of times, or more than, if you multiply an odd number of times, this is going to keep changing the sign back to positive and negative. So we're going to raise this to the third power, right? We're going to raise both sides to the third power, and then we have ourselves x plus 1 equals, now negative times negative is still negative, right? And 4 to the power of 3 is 64. Okay, so we subtract 1 from both sides, and we get x equals negative 65. Well, does this work, right? If you plug this into your calculator, 7 times the cube root of negative 65 plus 1, plug that into your calculator, you'll find that it is indeed equal to negative 28. So we are good, right? This is not an extraneous solution. It is the perfectly fine solution. So we've no problems with that at all. So once again, feel free to pause, try the last two problems on your own, and then we'll come back to it. We'll come back to it and see you on the flip side. So these last two problems here, let's take a look at them together, right? One of the things that we're going to focus on here is kind of the exponent rule, which deals with radicals, right? And I'm going to kind of show you on the side real quick this exponent rule that deals with radicals, right? You've seen exponent rules before. So essentially, the exponent rule for radicals is any number that's raised to a rational power, right? A fraction, if you like, right? Is the root, right? Let's be careful about this. This is the mth root, if you like, right? There's your index is m, the denominator, right? Your a is your base inside, and that a is raised to the nth power. So this is kind of the way this works. So you'll often see them as 1 over, so we don't actually use this most of the time. But this is strictly speaking, the exponent rule for dealing with radicals, right? So anytime we see a fractional exponent, and you've seen this before when you were looking at square roots, you see anything brought to the power of a half is a square root. Well, it works the same way in this case. So we can actually rewrite this at the very beginning. We can rewrite this whole thing in parentheses. We can go, okay, well, this is no different than 7 times the 5th root of x plus 1, right? And that's equal to 28. All right, so let's do our inverse operations. Divide by 7 on both sides. We now have the 5th root of x plus 1 equals, well, 28 divided by 7 once again is 4. That's no different. It's no change here. All right. So there's actually two ways of dealing with this. We've brought it into this way here, but I want to look at this here as well. So we know that all we're doing here, because it's the same as what we did before, all we're doing here is we're raising this to the fifth power. We're going to raise this to the fifth power as well, and we're going to get what we're looking for. But let me just, for a moment, let me bring this back to the starting problem, right? The starting problem that we had there a moment ago. All right, we're going to bring this all the way back to the starting problem right here, and we'll see that we've got exactly the same thing going on. So once again, if we had divided both sides by 7, we would then have x plus 1 to the fifth power, right, equals, in this case, 4. So what we're doing, if you notice, is when we raise both sides to the fifth power, right? If we raise both sides to the fifth power, once again, if you know your exponent rules, well, this exponent is multiplied times the outside exponent, right? Your exponent rule. So you have x plus 1 to the 5 over 5, which of course is just 1, right? Equals 4 to the fifth, right? So this solves as x plus 1 equals 4 to the fifth, right? So this is the same thing that's happening on this side. In this case, the exponents cancel out, and we have ourselves x plus 1 equals, so let's get to there. We've got x plus 1 equals, well, 4 to the fifth power. Check that on a calculator if you like. It's 1024, right? There's a nice number, 1024. So we're going to subtract 1 from both sides, and we get ourselves x equals 1023, right? So go ahead and punch that into a calculator, see if it works, see if go back to your original problem. You can either look at it in terms of this or in terms of this. It doesn't really matter which way you look at it, but essentially we plug it into the original problem. 7 times 1023 plus 1 raised to the fifth power, the 1/5 power, and if you plug that into a calculator, you will get 28, and that will indeed be true. Okay, so a few quick problems here to look at, for you to take a look at. I'm going to leave you to do those by yourself. At this point, you have everything you need to do that. If you've got any questions or comments, please leave them below, and I'll be sure to get back to you.